Hello everyone. So in this video I will be covering what is feature engineering, why do we use feature engineering, what are some of the different stages of feature engineering and some of the techniques involved in feature engineering. So what is feature engineering? Feature engineering is the process of transforming raw data into features that can be used to train a machine learning model. It involves selecting, creating and transforming variables, also known as features, in a dataset in order to make them more informative and suitable for use in a model. The goal of feature engineering is to extract and create new features that capture the underlying patterns in the data and make the data more informative for the model. So why do we do feature engineering? To improve model performance, to handle missing data, to handle categorical data, to reduce the dimensionality, to make the model more manageable, and to extract information. So I'll just covering each point one by one. To improve model performance. So one of the main reasons for feature engineering is to improve the performance of a model. By creating new features or transforming existing ones, we can capture non-linear relationships between variables and create features that are more informative for the model. And this can lead to a significant improvement in model performance. Next is handle missing data. Feature engineering can also be used to handle missing data by creating new features that are based on the available data. For example, you can create a new feature that indicates whether a value is missing or not. Next, handle categorical data. Some models can only handle numerical data, so feature engineering can be used to convert categorical variables into numerical ones. This can be done using techniques such as one-hot encoding or ordinal encoding. Ordinal means to be about order or the sequence. For example, shirt size, small, medium, large, so that can be encoded into ordinal encoding. Reduced dimensionality. Feature engineering can be used to reduce the dimensionality of the data by removing irrelevant features or combining multiple features into one. This can help to improve the performance of the model and make it easier to interpret, make the data more manageable. Feature engineering can also be used to make the data more manageable by grouping numerical variables into bins or aggregating data from multiple rows. Next is to extract information. Feature engineering can be used to extract information from unstructured data such as text or images. This can be done by extracting features such as word count, sentiment analysis, or image features like color histograms, texture, and shape. Different stages that are involved in feature engineering are starts with data exploration, feature selection, feature pre-processing, feature transformation, feature creation, feature selection, and finally evaluation. So data exploration, you will be exploring your data and understand the different variables and their relationships. This will help you to identify potential features and any issues with the data such as missing values or outliers. Next, feature selection. Once you have a good understanding of your data, you can select the most relevant features for your model. This can include removing irrelevant features, combining multiple features, or creating new features. Feature pre-processing. After selecting the features, you will need to pre-process the data to prepare it for use in a model. This can include tasks such as missing value imputation, scaling, and encoding categorical variables. Feature transformation. In this stage, you will apply various techniques to transform the data such as normalization, standardization, and binning. These transformations are applied to make the data more suitable for use in a model. Feature creation. You will create new features by combining or extracting information from existing features. This can include creating interaction features, polynomial features, and extracting information from text data. Next is feature selection. Once you have created and pre-processed the features, you will need to select the most relevant features for your model. This can be done using techniques such as correlation analysis, mutual information, or recursive feature elimination. Next is evaluation. After completing the feature engineering process, you will need to evaluate the performance of your model using the new features. This will help you determine if the feature engineering improved the performance of your model and whether any further improvements can be made. So basically you are comparing with the basic whatever features or the variables that you get, you create new features, all those things, then you evaluate your model without or different combination of features that you have combined together, what is the impact on the final model performance. So next is more important topic is the actual techniques used in the feature engineering. So these are the ones: one hot encoding, scaling, binning, aggregation, derived, extraction, interaction, and polynomial. So I'll be going through each one of them one by one. So first is one hot encoding. This technique is used to convert categorical variables, example color, size, into multiple binary variables, also known as dummy variables. This allows models that can only handle numerical variables to use categorical data. So basically we are these are the categories. For example, department in a company, if you have 10 departments, for example IT, HR, sales, marketing, support, sysadmin. So depending on all those, for example, for 10 departments, you will have 10 different categories and there will be one hot encoding. It will look something like this. For example, in this example, the data has 3 colors: red, green, blue. So there are total in this data set, to make you understand, there are only 4 rows, 4 records, and 4 records have 3 unique values: red, green, blue, and red again. So this is repeating. So because there are 3, so we have this has to be one hot encoded, because the computers or the machines cannot make any conclusions or model or based on these categorical data. So they will convert, for example, is red. So for red it will be 1. There will be one column added, is green, and because red is not green, so it will be 0, and is blue, so that will be 0. So 1 and last is 1 whenever so let's assume there are more rows with only these 3 colors: red, green, blue. So they will be marked with is red if they are red, 1 1, and for green, is green will be 1, and for blue, is blue will be 1. So the example which I give, for example, 10 departments. If you have department and there are 10 different unique values in your, for example, 1 million records, but you have 10 unique department. For example, IT. So there will be like is IT, is HR, is marketing, is sales, is support, and there will be 1 if it is yes, else it will be all zeros. Next is scaling. This technique is used to scale numerical variables so they have the same range of values. This is important because some algorithms use distance based calculations and the scale of the variables can affect the outcome. Common scaling techniques include normalization, which is basically scaling to a range of 0 to 1. So the values can be anything between it can be 10, 20, 100, 500, 1000, 1 million, but they will be scaled between 0 to 1. And second is standardization, scaling to have a mean of 0. So in this case, in case of standardization, the mean will be 0 and a standard deviation of 1. So it will be fluctuating between -1, 0 and 1. And for the normalization, it is between 0 and 1. So this example, you have age, actual data set without feature engineering. So if you have 18, 22, 35, 16 and 60 and 85. So if you do standardization, so this formula will be used. Standardization, just confirming. Yeah, if you sorry, this should be normalization. So if we do normalization, and this formula will be used. So x, so 18 minus x min. So in this case, min is 18 and max is 85 among all this data set. So 85 minus 18 will be denominator for all the values. Then first 18 minus 18, 0. So this is how it will be transformed. So it will become 0, 0.1, 0.3, 0.7 and 1. Next is binning. This technique is used to group numerical variables into discrete bins. Example, age. For example, there will be one bin for 0 to 18, 19 to 35, 36 to 50, 51 to 65, 66 plus. This can help to reduce the impact of outliers and make the data more manageable. For example, this is your data with this feature. So you have income 22,000, 35, 45k, 75k, 95k, and you can bin it. So you put a range like 20 to 40, 40 to 60k, 60 to 80, 80 to 100, and 100 to 120. So this will just automatically it will go and check what are the different ranges, and it will automatically, you can create, or the machine learning models can create these bins for you. Next is aggregation. This technique is used to create new features by aggregating data from multiple rows. Example, calculating the mean, median, or sum of variables for a group of rows. So this can be useful for creating features that summarize the data in a meaningful way. So an example would be, in this case we are doing the mean, the average. So we have data something like this. For the month of January, we have, for this for city, we have taken temperature. We have taken 3 readings. So in January 1st, 5th and 15th. Then we are going to second month. For February, we have 2 readings. So if we do the aggregation, we can just for these 3, we can just put a column month January, and we can just say average of these 3 readings, and for February also 1 reading. Next is derived. This technique is used to create new features by combining or transforming existing features. Example, calculating the ratio of 2 features or taking the log of a feature. So this can help to capture non-linear relationships between features. So something like this, you have Alice with weight and height we have taken, but we can transform it, and for the weight and height, because there is a formula for BMI, so we can take the height and weight and calculate the BMI formula and put in another column. And so for some machine learning model, probably this will add more value if we take this feature. So when we do the evaluation phase, we can compare the model with weight and height, and then a model with BMI, and probably one more model with all 3. So it will tell you which model has performed better, or what is the impact of adding a new feature like BMI. Next is extraction. This technique is used to extract new features from existing data. For example, you can extract features from text data like word count, unique words, and sentiment analysis. And you have Alice, Bob, and there's some date. For example, the data looks like this. There will be other columns also, but for the same, we'll add a day of week, and name and date is same, but we have added another column. This is we have extracted the day of week from the date. And for some machine learning model, for example, if you are trying to predict sales and all, so this will come handy. For example, if so the model will observe that there are always more sales on Saturday or Sunday, but less on Tuesday or weekdays. So it can actually predict. So this kind of so if we extract it, this will add much more value to the model, because day of week becomes suddenly more important rather than just the date. Next is interaction. This technique is used to create new features by combining 2 or more existing features. For example, you can create a new feature that represents the interaction between 2 numerical features, such as the product of 2 features or the ratio of 2 features. So these are just 2 techniques, that you can have product, ratio, you can have more, but in this case basically you have interaction of 2 or more features. So in this case, for example, we have Alice, Bob, and we have age and years of education. So they have so if we do interaction, we can have age and years, but we are adding one more feature or one more column, age into years of education. So we are just multiplying 25 into 16, 30 into 12, and 35 into 18. So the machine learning model probably have more value, because in this case, when we multiply, it greatly amplifies the importance of these 2 features. And for example, we are trying to predict what is the income, probably the predicted income. So because it has amplified, so probably age or some other factor together when multiplied would greatly influence the model performance. So last one is polynomial. This technique is used to create new features by transforming existing numerical features with polynomial functions. this can help to capture non-linear relationships between features. So it looks something like this. You have income, and for the polynomial, you can have income power of 2 and power of 3. So in some situation, even this can come handy, that the power of 2, power of 3, because it will greatly impact the predicted variable. So it can be income, or for example, it can, in the previous example, it could have been like years of experience. For example, if you want to predict someone's salary based on the years of experience. So as you know, the years of experience, for example, if you have 5 years of experience, 1 year of experience, 10 years of experience, if you have 5 power of 2, then it will become 25, and 10 it will become 100, because we know years of experience greatly impacts someone's predicted income. So in those kind of situation, it can greatly impact the model performance. And with that, that's all. Thanks for watching. Bye.